discuss the different types of matter. Okay, and it is homogeneous versus heterogeneous. And please remember, homogeneous is where it is the same. They're the same types of particles that are found in there. It looks uniform, whereas heterogeneous, when you look down at this picture, it is comprised of a variety of different items that are mixed together, and you can actually see the different particles. Okay, we also reviewed our examples of homogeneous and heterogeneous materials, and then we reviewed and practiced in the classroom and had different folks from each table to tell us, is it homogeneous or heterogeneous. Now we also talked about how matter can be classified. Is it a mixture where you can easily separate it, or is it a pure substance, an element or compound, where it's hard to break it apart, or it can't be broken down? It's in its simplest form. Okay, and remember, we're going to start here with the types of pure substances. An element, remember, is a substance that can't be broken down into a simpler substance. So things on the periodic table such as neon, gold, helium, boron, nitrogen, oxygen, all of those are examples. Compound is where you take two of those elements or more and you're actually combining them chemically. Now that's the catch word here, is chemically. And it's hard to actually go reverse and break it down. So example would be water, H2O, salt, NaCl, or sugar, C2H3O2. Okay? Now, here we have some ways. Let's say I have a mixture and I want to separate it. These are various methods that we use to separate those mixtures. The first one is filtering. Let's say I have sand and water all mixed together and I want to separate the sand from the water. An easy one to do is by filtering. So you would pour, like this coffee filter, you would pour water with the sand through that one. The sand would be captured in the filter and water would funnel through into a container. Evaporation is another one. So boiling or evaporating. If I have salt and water mixed together, just let the water either boil it out or let it naturally evaporate out. Then you're left with salt down at the bottom. Distillation is another unique method. This is where you actually take mixtures, let's say salt and water, and I wanted to separate it, but instead of letting the steam go out into the vapor, into the air, I want to capture it and then cool it and condense it down to separate it. So I have a pan of water and a pan of salt. This is the method. They do this down at the beach to purify the water and actually make it fresh water. They will heat it up and they will capture the steam and condense it down into a pot, and then you can collect that one and separate it from the salt. The last one, a fun one we'll do today in class, is chromatography, where you can see what colors are in markers and separate out those colors onto a coffee filter. Physical properties. So we have various different materials, and physical property is just identifying its characteristics that you can observe about a particular substance. And you're able to observe it without making any changes at all to that particular object. Some examples of physical properties could be viscosity. Now that's a very tough word there, but viscosity is like our honey or syrup or molasses. And where liquids that flow very slow are very viscous. Also, your appearance. I'm wearing a blue shirt today. I'm wearing a gray sweater today. Those are appearances. My hair color is brown. My eye color is blue. Those are physical properties. Hardness. This rock is very hard that I have to hammer it, or this rock is so soft I can break it up into bits and pieces with my hand. Conductivity. Can I create electricity with it? Malleability. Now that word right there means to bend it, to hammer it into shape. Melting point, for a substance to melt or to boil it, boiling point. These are examples of physical properties. Okay, a physical change though is when I actually take an object and physically change it without destroying its composition, its stuff that's inside of it. Just change its shape. So an example would be boiling. If you take ice and you melt it, here we're going to use melting and boiling in the same instance. Take ice in a solid form, you melt it, it goes to a liquid state. Take that same liquid and boil it, and it turns to steam, then you are changing its physical state. It's a physical change. Dissolving something in it, sugar dissolving in water. Well, I can evaporate the water out and I can get that sugar back. Shredding paper, tearing paper, cutting grass, cutting your hair. These are all examples of a physical change. A chemical property, these are characteristics that a substance will undergo to change from one form to another. So some chemical properties that we have are flammability, the ability for a substance to burn. Combustibility, and that one is the material will be combustible, where it will explode. Or reactivity, having a substance undergo chemical change and combining with other substances. A chemical change, though, is one where you will change from one substance into a brand new and a different substance. Some signs of a chemical change are a color change, and not just identifying it's a red color. You're changing from a blue to maybe a purple color. That would be a color change. Production of a gas. If you see bubbles and not boiling, if you put an Alka-Seltzer tablet in water and you see it fizz, then that would be an example of production of a gas. Precipitate. When I will try to demonstrate that precipitate for you, but if you mix two liquids together and you get something that falls out, and a solid falls out, that would be a precipitate. Release of energy. If it produces light, like the glow sticks here, or an explosion happens, then that is a sign of chemical change. Okay? Thank you. All right. And we will continue with some practice worksheets on physical and chemical change. Thank you.